In 2025, a company in California announced something that sounds almost impossible: a battery factory so big it could power 4 million homes. And every single unit it will produce for the next year and a half is already sold. The factory has not even been built yet. The first brick has not been laid, but the orders are locked in, signed by industrial buyers who are willing to wait. What makes this even more remarkable is what is inside those batteries. No lithium, none. Instead, they use sodium, a material so common and so cheap that it could change the way entire power grids operate. For years, people watched China pour billions into sodium battery factories while the West sat on the sidelines. That is about to change. A company called Peak Energy is building America's first sodium-ion gigafactory in Sacramento, California, and the numbers behind it tell a story that goes far beyond one building. It is about cost curves, moving parts, and a chemistry that has been hiding in plain sight. If you are enjoying videos like this, please hit the like button because it takes a lot of effort to make these, and subscribe so you do not miss the next one. What you are about to hear is the story of how a simple element became the center of one of the most important manufacturing announcements in recent American energy history, and why the utilities lining up for these batteries are not doing it out of curiosity. They are doing it because the math finally works. But to understand why, you first need to understand what makes sodium so different from everything that came before it. Why sodium changed everything. For most of the battery world, lithium has been the king. It is inside your phone, your laptop, and most electric cars. It is light, it holds a lot of energy, and it has been refined over decades. But lithium has a problem that nobody likes to talk about. It is expensive, and it is not everywhere. To get it, companies dig it out of the ground in places like Chile and Australia, process it, and then ship it halfway around the world. That supply chain works, but it adds cost at every single step. Now think about sodium. Sodium is in the salt in your kitchen. It is in the ocean. It is in deposits all over the planet. You do not need to chase it across borders or fight over limited mining claims. It is one of the most abundant materials on Earth, and that changes the economics of battery manufacturing in a way that is hard to overstate. In a phone or a car, weight and size matter a great deal. You want the most energy packed into the smallest possible space. That is where lithium shines. But for grid storage, the batteries do not move. They sit in a field or inside a warehouse. They do not need to be light. They need to be cheap, reliable, and able to charge and discharge thousands of times without falling apart. Energy density, which is the amount of energy per pound, is far less important. That is where sodium becomes an extraordinary choice. It is not about feelings or trying something new for the sake of it. It is about simple economics. When the material going into your battery costs a fraction of what lithium costs, and the battery does not need to fit inside a vehicle, the entire cost structure shifts downward. Chinese companies like CATL and BYD figured this out years ago and started pouring billions into sodium chemistry. They saw the curve before anyone else in the West did. For a long time, that left American utilities watching from the sidelines, buying lithium systems at higher prices or waiting for the technology to mature. But sodium is not just about being cheaper. It also handles temperature swings better than lithium in many cases, and it can be built using manufacturing lines that are similar to lithium lines with modifications. That means a company does not have to reinvent the entire factory to switch chemistries. This detail matters more than it seems. It is one of the reasons sodium has been called the sleeping giant of stationary storage. It has been sitting there, ready, waiting for someone to build the factory. And now someone finally is. But to understand how big this factory actually is, you need to look at where it is being built and what it will produce. The Sacramento Megafactory. The factory is being built in Sacramento, California, inside the Metro Air Park industrial area. The building itself covers 183,000 square feet. To put that in perspective, that is roughly the size of 3 large supermarkets placed side by side. It is a serious industrial space, not a small pilot line or a research lab. This is designed for real production. Peak Energy chose Sacramento after running a nationwide site search. They were not just looking for cheap land. They needed access to industrial workers who knew how to build things, and they needed logistical connections to the Western power grids. Sacramento ticked those boxes. It has a skilled workforce, rail and road links, and it sits close enough to the large utility networks in California that the batteries can be deployed where they are needed without long shipping delays. The money behind this is real too. The initial capital expenditure is $71 million. That covers building construction and equipment installation. On top of that, California awarded $10.5 million in tax credits through its Cal Competes program in May. That state support is a signal. California does not hand out tax credits for projects it thinks are speculative. The state looked at the plan, ran its own numbers, and decided this factory was worth backing. Once the factory is running at full capacity, it will produce 4 gigawatt hours of battery systems every single year. A gigawatt hour is a massive unit of energy storage. 4 gigawatt hours is enough to supply electricity to roughly 4 million households. Now, some people might look at that number and say it is not huge compared to what China is building. And they would be right. Chinese gigafactories are operating at scales that dwarf this. But that misses the point entirely. This is the first factory of its kind in the United States. It is the opening move, not the final one. The fact that it exists at all is what matters. The factory is expected to create 240 local jobs in assembly, logistics, and technical operations. Those jobs flow outward too. Parts suppliers, freight companies, and maintenance contractors all benefit. A factory like this does not just sit in isolation. It pulls an entire local supply chain along with it. First production and shipments are scheduled for the first quarter of 2027. That means within roughly 18 months of breaking ground, batteries should be rolling out the door and heading to utility sites. But what makes this factory truly interesting is not just the size or the location. It is what the batteries inside it do differently from anything else on the market right now. The genius of no moving parts. Here is where the design gets genuinely clever. Most large battery installations need active cooling, fans blowing air across the cells, liquid pumps circulating coolant, mechanical systems that keep the batteries from overheating when they are charging and discharging at full power. These cooling systems work, but they come with a hidden cost that adds up over years. Think about what happens to a fan sitting in a field for 20 years. Dust gets in, bearings wear out, motors fail. A pump that circulates liquid coolant has seals that can leak, valves that can stick, and pipes that can crack. Every single moving part is a maintenance bill waiting to happen. And in a utility-scale battery installation with thousands of cells, that means thousands of potential failure points. Peak Energy eliminated all of it. Their sodium-ion storage systems are passively cooled. No fans, no liquid pumps, no mechanical cooling components of any kind. The battery cells are designed in a way that lets them manage their own temperature without any active help. This is not a small engineering detail. It is a fundamental shift in how the system ages over time. When you strip out every moving part, the long-term operating costs collapse. There is nothing to replace. There is nothing to service on a monthly schedule. A utility can install these systems in a remote field, connect them to the grid, and leave them alone. That is exactly what grid operators want. They do not want to send technicians out to remote sites every few weeks. They want batteries that sit there quietly and work. Peak Energy says their sodium-ion systems reduce the cost of energy storage by 20% compared to alternatives. They also guarantee 99% uptime. That means the batteries are available 99% of the time, ready to charge or discharge whenever the grid needs them. For a utility, that number is enormous. A 1% difference in uptime across a large installation can mean millions of dollars in saved costs over the lifetime of the system. This is not just a lab theory either. Back in August 2025, Peak Energy connected a sodium-ion pilot system directly to the American grid. The chemistry they used was sodium-ion pyrophosphate, and at the time, it was the largest operational deployment of that specific chemistry anywhere in the world. They proved the technology works in real conditions, not just on paper. That pilot run gave utilities the confidence to sign real contracts. And those contracts are the next part of this story. Already sold out before it is built. This is the detail that separates a real factory from a press release. Peak Energy is entering the market with 6 gigawatt-hours of advanced product orders already under contract from industrial buyers. Let that sink in for a moment. The factory will produce 4 gigawatt-hours per year when it reaches full capacity. The orders already on the books total 6 gigawatt-hours. That is a year and a half of full production, sold before the factory is even built. In manufacturing, this is called an order book, and it is the single best indicator of whether a company is serious. Anyone can announce a factory. Anyone can put out a rendering of a shiny building and talk about the future. But when industrial buyers sign contracts for 6 gigawatt-hours of capacity, they are putting real money on the line. They have looked at the technology, evaluated the costs, and decided this is worth committing to. So who is buying? The answer tells you exactly why this is happening right now. AI data centers are putting enormous strain on American electricity grids. These facilities consume power at rates that were unimaginable just a few years ago. They run 24 hours a day, 7 days a week, and they need that power to be stable and reliable. When a data center pulls massive amounts of electricity, it stresses the local grid in ways that can cause instability. Utilities are desperate for storage they can deploy quickly and run cheaply over a long period. Sodium-ion batteries fit that need almost perfectly. They genuinely deliver over 10,000 charge and discharge cycles. That means a battery installed today could cycle every single day for more than 27 years before reaching the end of its rated life. For a utility planning decades ahead, that kind of longevity is exactly what they want to see. The combination of low cost, high cycle life, and zero maintenance cooling is what drove these orders. The buyers are not gambling on experimental technology. They are buying a product that has already been tested on the grid, that uses materials that are abundant and cheap, and that is backed by a company with a factory under construction and state tax credits in hand. Peak Energy CEO Landon Mossberg said this facility is proof that America can lead, not just in inventing technology, but in building it at scale. Whether you call it leading or simply catching up, the point stands. The factory exists, the orders exist, and the timeline is real. First production in early 2027 means that within about 18 months, these batteries will be connected to grids across the western United States. But the bigger story is what happens after that, when the cost curve starts to bend. The grid of the future. Think about how the American power grid actually works right now. Solar panels across California produce enormous amounts of electricity in the middle of the day. So much that grid operators sometimes have to curtail it, which means they literally turn off solar farms because there is nowhere to put the energy. The sun goes down, and those same grids start pulling power from natural gas plants to meet evening demand. This daily cycle is one of the biggest inefficiencies in the entire energy system. Now picture a field full of sodium-ion batteries. During the day, they soak up cheap solar power that would otherwise be wasted. At night, they feed that power back into the grid when people turn on their lights and their air conditioners. No fuel burned, no emissions from a smokestack, just stored sunlight, delivered hours later. This is not a distant dream. It is the economic model that makes the Sacramento factory relevant. When storage gets 20% cheaper and maintenance costs collapse because there are no moving parts, the combination of renewables plus storage beats everything else on pure economics. Not ideology, not policy, economics. The numbers simply work. Consider what happens to that model over time. The first factory produces 4 gigawatt hours per year. If the demand is there, and the 6 gigawatt hours of orders suggests it is, a second factory becomes an obvious next step, then a third. Each one benefits from lessons learned in the previous one. Manufacturing costs drop as volumes rise. Suppliers move closer. The entire supply chain tightens and becomes more efficient. This is how every major manufacturing industry has evolved, from cars to semiconductors to solar panels. The global picture is even bigger. Roughly 90% of the world's population lives in the Sun Belt, the band around the equator, where solar energy is abundant year-round. Cheap sodium batteries combined with cheap solar could transform energy access across enormous parts of Africa, South Asia, and Latin America. Places that never had reliable electricity could skip the fossil fuel era entirely and go straight to solar plus storage. That is a future that sounded impossible 10 years ago and sounds inevitable now. The Sacramento factory is one building in one city in one state. But it represents a pivot point. It is the moment when sodium-ion manufacturing stopped being a Chinese story and became an American one too. The technology was not invented yesterday. The materials are not exotic. The buyers are not guessing. Everything about this is grounded in real engineering and real contracts. The question now is not whether sodium-ion works. The pilot already proved that. The question is how fast it scales, and how quickly the old way of running the grid becomes the expensive way. If you enjoyed this story and want to see more like it, hit the like button, subscribe, and turn on notifications so you never miss the next one. There are related videos on the screen right now if you want to keep watching. So here is a question for you. Do you think sodium-ion batteries will eventually replace lithium for grid storage? Or will lithium find a way to stay competitive? Let me know in the comments.